Hello students, and welcome to today's lesson on writing, reducing, and expanding ratios. In this lesson, we are going to focus on 4 essential questions. The first is, what is the ratio? And by the end of this lesson, I would like you to be able to describe the parts of it. I also want you to relate to something that we've already been studying, which is fractions. I want you to be able to know how fractions relate to a ratio. I also want you to be able to write a ratio for a given situation and to be able to reduce or expand a ratio to look at the relationship a little bit differently. Now you may be thinking, what is a ratio? But you've encountered them many times in your life. They're all around us. Your iPod, your computer screen, they have what's called an aspect ratio. A width to height ratio. Your iPod has a height to width ratio as well. When your house was built, perhaps it has a basement that required cement. When building cement, we have to ensure it has a proper ratio. 1 part cement to 3 parts sand, and there would be another piece to that ratio, and that would be the water. Matchbox cars have a ratio called a scale. Every 1 inch on the Matchbox car is 64 inches on the car that it was modeled from. At the grocery store, there are unit prices, which is a special type of ratio. It tells you how much it costs per 1 item, in this case pound. Cameras, like computer screens, have aspect ratios, width to height ratios of the picture. So you've seen ratios, so what are they? A ratio is a comparison of 2 amounts. When you write a ratio, all you're doing is making a comparison between 2 numbers, 2 amounts. It states a relationship between 2 things. How is one thing related to the other? You may be on a field trip and you might say, well, here's 1 teacher and 10 students. You've made a relationship into a comparison. 1 teacher to 10 students. Or it could be written this way with a fraction bar. 1 teacher to 10 students. I preference you to write it this way because later we will learn to expand ratios and also use cross products to solve for a missing variable. So I would like to see you focusing on this method. You can also write the word to instead of the colon or the fraction bar. So you could literally write 1 teacher and then the word to 10 students. So in our previous unit, we talked about fractions a lot. Fractions and ratios are very closely related. Remember, a ratio compares 2 amounts. Similarly, a fraction compares 2 amounts. It's just that it's 2 specific amounts, the number of parts that make 1 whole. A fraction is a type of ratio. So not only have you seen ratios in the past, you've worked with them. Fractions are a special type. Remember we just talked about ratios and how they can be written, and they can be written in 3 ways, using a fraction bar, the word to, or with a colon. Fractions, we learned in our previous unit, can be written in 3 ways as well, a fraction, a decimal, and a percent. This is a difference between the 2. For a ratio, we must label the 2 parts of the ratio since they can be different units. Remember in that last slide, we said 1 teacher. We labeled what that 1 meant. To 10 students, we labeled what the 10 meant. For a fraction, we do not have to label the units because they have the same units. If I say, you got a 9 out of 10 on your last homework assignment, you know that that's 9 questions out of 10 questions. I don't have to tell you the units because they are both the same. Let's look at this real world situation. Did you know that every time one aluminum can is recycled, enough energy is saved to run a television for 4 hours? That impressed me. So you can visualize this. One can leads to 4 hours of television time. So I ask you, would 2 cans to 8 hours represent the same ratio? Could I replace this statement with 2 aluminum cans and 8 hours of energy? And the answer is yes. You can visualize this same relation, 1 can to 4 hours, 1 can to 4 hours, 2 times to get that 2 cans to 8 hours. So yes, that represents the same relationship because 2 cans to 8 hours is 1 can to 4 hours 2 times. This is called expanding a ratio, and we can do the opposite as well. We can reduce the ratio. When we do that, we create an equivalent ratio, which is one that represents the same relationship. What that means is the same relationship is occurring over and over. It's just more or less times in a larger group or a smaller group, perhaps, depending on what you're talking about. So to create this equivalent ratio, you can multiply by a common factor to expand the ratio or divide by a common factor to reduce the ratio. Let's look at an example. Let's say you're playing a game with a number cube and someone makes this statement to you. There is one even number for every one odd number. Does that mean that there is only one even number on that dice? And the answer is no. We know that there's 6 sides to the dice. So we could expand this ratio by 3 to get 3 even numbers to 3 odd numbers. This is an equivalent ratio because there's still one even for every one odd. Let's look at another example. In a package of marbles, there are 30 blue marbles and 20 red marbles. Isn't that a comparison of the contents of the package? So you can imagine there's 30 blue for 20 red. I do not mind if you abbreviate your units for me. If it was your PSSA, I would want you to write them all out. If it's a word that starts with an O, you need to write it out because if not, it would look like a 0. Okay? So here we have 30 blue for every 20 red. Now you can imagine if I bought a package of marbles, perhaps I want to split them, between my friends or into smaller packages. So I can reduce this ratio. Maybe I want to make 10 packs. So I can divide by 10 to create 10 packs. Every pack would have 3 blue for every 2 red. So we have 30 divided by 10 makes 3. 20 divided by 10 makes 2. So this is a reduced ratio. It represents the same relationship, just in a smaller scale. So let's look at a practice problem. There are 15 boys and 12 girls going on a field trip. Write a ratio to describe the students going on the field trip. So we have 15 boys and 12 girls. That describes the students. That's a relationship. who is going on the field trip. Now, are we likely to stay in a whole group on the field trip? No, so maybe we want to reduce that to see how we could make even groups. What number can both 15 and 12 divide by? Both can divide by 3. They both have a common factor of 3. So 15 divided by 3 makes 5. So we put 5 boys in each group. 12 divided by 3 makes 4. And we put 4 girls in each group. This is a way that we have reduced the ratio. Last year at Phantom Meadow, there was a ratio of 18 students for each teacher. What does the word each imply? How many? 1. So when we write this ratio, we would describe it as 18 to 1. So let's think about expanding this 18 students to 1 teacher ratio. If we know that there's really 7 middle school teachers, expand the ratio to show how many students there would be for 7 teachers. So what would I have to expand the first ratio by to end up with 7 teachers instead of 1? I would need to multiply by 7. 18 times 7. 7 times 8 is 56. 7 times 1 is 7, and 5 more makes 12. So we would have 126 students between all 7 teachers. Remember, each one of them still has 18, but there would be 126 altogether. It's a way of looking at the ratio expanded. Did you know that right now Ben Roethlisberger is under a 8-season contract worth $102 million? And that means he is going to acquire $102 million if he plays 8 seasons of football. Wow. If we reduce that, we could look at how much he would make per season. Notice, season is a singular word, so that means we're looking for 1 season. What would we have to divide 8 seasons by to get 1 season? We'd have to divide by 8. So if we pull our calculator up and we divide $102 million and we divide that by 8, we get 12,750,000 for every season of football that Ben Roethlisberger plays. We've reduced the ratio to look at a smaller amount of time, 1 season, instead of 8. Now, we can also use ratios to compare. If we know Marcus earned $230 in 40 hours, and Philip earned $192 in 32 hours, it's hard to know who really earned the most per hour, meaning 1 hour. But if we reduce them to get 1 hour, we can then make a comparison between Marcus's earnings and Philip's earnings because it's represented by the same amount of time. So how do we reduce 40 hours to 1 hour? We would divide by 40. How do we reduce 30 hours to 1 hour? We would divide by 32. I would like you to finish this problem. Reduce these ratios, and then in class tomorrow, we will describe who earned the most money per hour.